Hi everyone, welcome back to this class. In today's class, we will cover the range and endurance part. So, what is endurance? Endurance is, say, for example, if you for a given amount of fuel, how long you can fly in a air, that is endurance, and what the distance you will cover will be the range. Okay. So, if you are flying with a piston engine, piston propeller combination, then the scenario will be different. And if you are flying with the jet, the scenario will be different. So, in both the cases, we will discuss the range and endurance part. Okay. So we will start with dwf by dt equal to minus ct into t, where is nothing but the wf nothing but the weight of a fuel. Okay, so dwf by dt is the rate of change of fuel weight. Okay, and then ct is nothing but the specific fuel consumption, and t is thrust. So you can define the ct as a to produce the unit thrust in unit time, how much fuel is required, that is nothing but the specific fuel consumption. So if this value is more, that means engine is taking more fuel. Okay, and if this value is less, so engine is taking less fuel. Okay, per unit time in a 1 second. Okay, so what you want less fuel consumption or more fuel consumption? Okay, so now see, dt is written here, right? Dt is nothing but the time, and if you integrate the time, this dt you will get the total time. And what I said with the definition, total time is endurance, right? So you take dt at one side. Okay, dt one side, and dwf minus c t into t. And why minus sign? Because at every instant your fuel is consuming, right? Decreasing, right? So that sign indicates negative. Okay, now when you are flying at a steady state level flight, so what is your thrust? Drag, right? Thrust required is drag. We have already seen this, right? This you can further rewrite as ct into d, and you can multiply by w. Okay, numerator and denominator multiply by w, and denominator you are also having a w. So in also a steady state level flight, lift equal to weight, right? So this w you can replace by lift. So I can take 1 upon ct, and this I will replace by L, and this is W, and this is D. So L by D I will take separately, and dW F by W I will take separately, right? So now I can write dt equal to minus 1 upon ct L by D dWf by W. So let's say your total takeoff weight is W naught, and by burning the WF fuel, your remaining weight is W1. So W1 plus WF will be W naught. And if you differentiate this W naught WF, and this is remaining weight you call it a W, and you differentiate it, this value is constant, so dWF by dt will be dW by dt. Okay, so you can write dWF by dt equal to dW by dt. Okay, so now integrate both sides. Integrate name it as equation 1 and this is equation 2. Okay, so E will be minus 1 upon Ct L by D, and this will be ln W, and your starting weight is W naught and final weight is W1, right? So E 1 upon Ct L by D log W1 minus log W naught if you open this. So this you can further write from the log. Okay, now this is minus sign, you just reverse this, so minus 1 will come here, and then from the log arithmetic properties this minus 1 and this minus 1 will make it positive, and finally you will get this expression ln W naught okay. Okay, this is nothing but the E equal to 1 upon Ct L by D ln W naught by W1. So this is the endurance for a jet powered aircraft, where Ct is a specific fuel consumption, L by D is the aerodynamic efficiency, W naught is your initial weight, and W1 is a after consuming the WF weight. Okay, now you can see if you fly at a L by D max, your endurance will be maximum, and if you fly at a lower fuel with a lower fuel consumption, your endurance will be maximum. Okay, for jet powered aircraft, this is for jet powered aircraft. Pro piston or rotary engine powered and propeller driven. Okay, so when you go with this type of engine, piston engine, propeller, where you have a piston internal combustion engine connected with the propeller, which is used to provide the required thrust. But when we go with this type of engine, we generally deal with the power. So similar expression you can rewrite here, dW by dt equal to minus C into P. So in previous case we have used thrust, but here we are using power. So for a jet engine we use thrust, and for a propeller piston engine powered and propeller driven aircraft we use power. In that case the specific fuel consumption was Ct, but in this case it is C. Okay, so now we will again rearrange this equation, and we can write dWf C into P. And what is power required? Power required is again thrust required into velocity. Okay, and this thrust required you can further rewrite drag into velocity. The same thing you will do, put W here, make it lift, and then divide by W here, you can make it L by, and put drag D this side, so L by D, and 1 upon C, or you can write like this, 1 by C, L by D, dWf by W, you divided by W and multiply by W, and thus you make it L, and you can rewrite L by W like this. And V you can write from lift equal to weight, 2W divided by rho SCL, because everything you have to convert in terms of W here, velocity, right? Because if you do not convert and if you integrate, then velocity is also function of W, right? And you are integrating the W part, right? And now in this expression, if you integrate, you will not find any problem, since rho is constant at one particular altitude, S is constant, you have size your aircraft, okay, and CL and CD, you are flying at one particular CL and CD, and just you are integrating with the W, okay. So now if you arrange, what you will get, you will get this rho S will go at the top, and this L by D you can write CL by CD, and this CL will go and it will make CL power 3 by 2, okay, and this rho into S will go up, and this is root 2, please correct me if I am missing anything, okay, and this is dWf by W power 3 by 2. So now E equal to minus 1 upon C CL power 3 by 2 CD, and if you integrate, since this is dt, if I will integrate, it will become E, and here it will be minus 3 by 2 plus 1 minus 3 by 2 plus 1, and this limit start from W0 to W1, okay. Now this the answer will be minus 1 by 2, and this minus and minus will become plus, and this is CL power 3 by 2 CD, and here you multiply by rho S by root 2, and here you can write this 2 will go up, and this root 2 by root 2 divided by root 2 will make it root 2, and this is rho S, so you can write finally 2 rho S, and this you can write W minus half W not minus half, okay. And since if you consider the propellant efficiency, so here you can multiply by eta PR into C, because whatever the power the engine is producing, you will not get the same, right? So eta PR C. So here also you can see what I said, CL3 by 2 CD max condition, right, where the power is minimum, right, power minimum condition. So if you fly at power minimum condition, you will get maximum endurance, and if your efficiency as close to 1, which is not possible, but if you even if you have a 0.7 0.8, it is called good efficiency, propulsive efficiency, then you will have a good endurance. If a specific fuel consumption is low, again endurance will increase. If this value is getting low and low, this value will keep on increasing. Okay. And if you will carry lot of fuel, you will have a more endurance. Okay. So this is the range and endurance part for the jet powered aircraft and this propeller driven aircraft. Similarly, we'll cover the range part also. So we'll start with the same equation. For first case, jet engine. Okay. So for a jet engine case, we will cover, right? So we'll start with dWf by dt, which is minus Ct into T, again dt minus dWf into Ct into T, and if you multiply with the time, what you will get? Velocity only, right? Okay, so here I will multiply by V at which you are flying, minus dWf Ct, and this I will write as drag, thrust required equal to drag, and into velocity V. So okay, if you substitute this V and divide by W and multiply by W, you can rearrange 1 upon Ct, or we'll start from the new line, new slide. Okay, V equal to V into dt equal to 1 upon Ct dWf by d into V. Okay, we'll go step by step. 1 upon Ct, and you multiply by W and divide by, and you substitute this V as a 2W rho S Ca. Okay, now 1 upon Ct, this further you can write L by D, you can rewrite Cl by Cd, and this Cl, take this Cl, and finally this will become Cl power 1 by 2 by Cd, and 2 rho S dWf minus half. Okay, correct, right? So if you integrate, you will get V into E and 1 upon Ct Cl power 3 by Cl power half Cd, and 2 divided by rho S, and this minus half plus 1, half plus 1, and the limit will be W naught to W1. So this 2 you can write here, and this Cl power 1 by 2 by Cd, 2 divided by rho S, and this will be the plus, right? So W naught power half W1 power plus half. If you apply the limit and take a minus sign common, this minus minus will become plus, and whatever 1 by 2 you are getting here, this 1 by 2 will come as a 2 here. So 2 divided by Ct Cl power 1 by 2 by Cd under root 2 divided by rho S into W naught half minus W1 half. So from this expression also you can observe, if the specific fuel consumption is low, your range will be high, and V into is range. Simple. Speed equal to distance upon time. So here also you are assuming there is no acceleration, right? Aircraft is flying with a constant velocity. And if you are flying with a CL power 1 by 2 by CD condition, max condition, R will be the maximum. And if you carry lot of fuel, then also you will having a high endurance. Okay, more endurance as well as a more range. So range we have covered for a derive for a jet engine case, and similarly we will derive for a propeller case. Okay, so you again start with d w by dt equal to minus c into p. So remember here, if anybody asks you what is the range, what is the endurance for a jet, for a propeller, then you just think that okay, for a jet I generally deal with the thrust. So you start with this equation only, dw by dt, what the weight is consuming, fuel weight is consuming, and you then everything you will derive, and procedure remains the same. It is very easy, right? If you remember this equation, as long as propeller is concerned, put P, and for jet put T, and then again you thrust required equal to reg, lift equal to weight, integrates, everything remains same only, right? So no need to remember the formula. You can derive within a 2-3 minutes. Okay, but here you have to be very careful, right? While integrating, you have to see that integrating making sense or not, because if you didn't convert the V in terms of W, you will not be able to integrate, because V is a function of W and you are integrating the W also. Okay, so these kind of things you have to keep in mind. Rest are okay. Okay, so P again you can write P into V. What you will multiply by with the endurance in order to get the range? Velocity, right? So if you multiply by the velocity, then velocity will get cancel. So what are the terms remaining? C into T, and this is range. Are you aware of this? Little bit similar type of things we have done previous. So directly you can write the expression, but anyhow we will drive the same. So V into dt is what? V into dt is minus dwf C into T I will put D, and here I will divide by W and multiply by W, and this I will call as a L, and this I can write L by D, and then dwf divided by W. Simple. Now if you integrate, you will get V into E. If you integrate dt, you will get E, and here 1 by C L by D. Okay, and this is ln W naught by W1, and this will be the positive, and if you multiply the propeller efficiency, this will be the okay, and this you can call it as a range. So which is similar to something, right? See, endurance of a jet is 1 by Ct L by D ln W1 by W1, and range of the propeller is eta PR by C into L by D ln into W0 by W1. Okay, So you can stabilize the relation between CT and C also. In generally many books you will find that when you convert the things from the jet engine to propeller, they used to stabilize the relation between CT and C and then derive this the same. But here I have not done. Here I just use this concept. The concept is dWf by dt into CT into T. So here when I am dealing with the jet I will put CT. If I am dealing with the propeller I will put C. I will put power here. Okay. Now at the end, if there is a propeller, I will put the efficiency part here at the end of. And generally, when you start with the relation between CT and C, the propeller efficiency will be taken account. And from the beginning, you will see this term eta PR, eta PR, eta PR. Okay. So it's your up to your choice ना. आपको जो अच्छा लगता है रिमेम्बर करने का आसान तरीका वो आप कर सकते हो. तो मैं आपको फिर से ब्रीफ कर देता हूं कि व्हाट यू हैव डन सो फार. द पर्पस वाज टू फाइंड द रेंज एंड endurance for a jet as well as a propeller. Okay. Aircraft. Okay. Now I have written dWf by dt into minus CT into T, equation 1, and then if I am interested to find the endurance, I will take the dt one side, rest of the term will be other side. Okay. I will integrate, but before integrating we have to rearrange the things, like thrust required equal to drag and divide by W multiply W. If you arrange everything, integrate in terms of W, you will get the expression. And in all the cases we have done, and we have stabilized the two range equation and two endurance equation, two range and endurance for propeller, range and endurance for jet. Okay. And now without seeing the expression, you can see that कि okay, अगर हमारा फ्यूल कंजम्पशन लो रहेगा तो हमारा एंडोरेंस बढ़ेगा. कोई मैथ नहीं. देखो मैथ से आ रहा है कि नहीं. इन ईच एक्सप्रेशन द सीटी इज इन डिनोमिनेटर ओनली. ठीक है. अब दूसरा देखो, दूसरा ये भी था कि हमारा एल बाई डी जो है, अगर हमारा एल बाई डी मैक्सिमम एरोडायनामिक एफिशिएंसी पे फ्लाई करेंगे तो हमारा रेंज एंड एंडोरेंस अच्छा आएगा. ठीक है. अब although कि it is not exactly L by D max, in some cases is CL power 3 by 2 by CD max, but एक सेंस बनना है ना कि CL मैक्सिमम है और तो CD मिनिमम है थोड़ा, तभी ये अचीव कर सकते हो. ओके. और इवन एंडोरेंस के केस में हमने एग्जैक्टली देखा कि आप अगर मिनिमम पावर रिक्वायर्ड की कंडीशन में फ्लाई करते हो तो हमने क्या देखा था, CL पावर 3 by 2 by CD था ना. अगर CL पावर 3 by 2 by CD अगर मैक्स होगा तो पावर मिनिमम होगा. अगर इंजन से पावर मिनिमम आ रहा है तो आप ज्यादा देर तक हवा में रह सकते हो कि नहीं. तो ज्यादा देर तक हवा में रहना ही तो एंडोरेंस की डिफिनेशन है भाई. एक बार आपने फ्यूल भर दिया, आप कितना देर तक हवा में रहोगे, दैट इज नथिंग बट द एंडोरेंस. और आप कितनी देर तक चलोगे, दैट इज नथिंग बट द रेंज. तो मिनिमम पावर लगेगा तो आपका एंडोरेंस ज्यादा होगा. ठीक है. तो इट्स ऑल अबाउट रेंज एंड एंडोरेंस. तो थैंक यू. विल टेक ब्रेक. ओके.